Hello everyone. In our previous video, we discussed about machine learning. Now in this video, we are going to discuss about types of machine learning. So, what are the types of machine learning? Machine learning is divided into four types: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. We'll see all these learning one by one. First, we'll go to supervised learning. Supervised learning is nothing but which has some labeled data, and a teacher is there for is there to teach. So this is basically the concept of supervised learning. Supervised learning are of two types: classification and regression. So you might be thinking, what is labeled data and unlabeled data? So labeled data is nothing which has some features in itself, or some attributes which is important to it. So that's why we think of it as a suppose we have a flower. That flower is white in color, so that the color is the attribute which differentiate that flower from other flowers. So that is the label data, that this is a flower, it is small. That is a tree is tall in shape. So this is the difference between labeled data and unlabeled data. Here we can see in this example, a data set is not always be a number. Here we have taken an example of a flower, and then these attributes like the length of the petal, width of the petal, length of the sepal, width of the sepal, and the class. Class is here a target or dependent attribute. Like based on these attributes, a class is determined. Like, okay, it is a setosa. So based on these attributes, it is determined that the flower is setosa. So these are the independent attribute, and the class is a dependent attribute. So like this, the data label data will be given to you, and then according to that, you have to use that in supervised learning. So here we are given an image. So as we can see, that we can classify that this is a dog and this is a cat. But eh, in s- in machine learning, we have to give this data and we have to give it a class like cat, and then we have to give this image a class like dog, and then only it can classify, okay, this is a dog. After seeing this image, if you remember, we have taken an example of object detection in an image. So suppose we have given a data set to train our model, that the picture, this picture is of a dog, and this picture of a cat is of a cat. So what happens is, whenever our we give an image as an input, so whatever image we give, if inside that image a cat is there, the similarity between these two images will be seen. So the machine learning model will classify this image as a cat image. This is how it works. Second, this one is an unlabeled data set. Here no labels are given, and the machine cannot detect, like, um, what is this image, what is that image, so it cannot classify this. In this one, what it does is, it will classify these both images, like it will distinguish between these both images. Unlabeled data set is used in unsupervised learning. So there is no supervised or anything to which is used to train the model. So what it does, it takes a image. Suppose it's a dog cat image. This is a cat image, and uh, the cat has strong eyes, we can say. So it is an attribute. The is an attribute. So based on this attribute, we'll classify all the images and differentiate between all the images, that okay, it is a cat image. This is how supervised and unsupervised learning is done. So I think you have got an understanding about labeled data set and unlabeled data set. So now I come to supervised learning. So supervised learning uses the labeled data set, as I told you, and as the name suggests, there is a supervised or a teacher. In the supervised learning, they provides a labeled data set, and then the model is constructed and it generates the test data. It happens in two stages. The supervised learning algorithm takes place in two stages. First, in layman terms, during the first stage, the teacher will communicate and give the information to its student that the student needs to understand, and it needs to receive that information, and it needs to understand that information. And the teacher has no knowledge that whether that actual information has been taken up by the student, whether they know the all the concepts. And the second stage will be when the teacher asks a set of questions to the students about that information which is given by the teacher. So based on this question, the teacher takes the assessment, like how our class learning, it is similar to our class learning. Whatever teacher teaches in class, it is asked in the exam internal. Suppose we take an example of internals. Whatever he or she teaches in class, those questions they ask in exam, and according to that they evaluate each and every student. So this is nothing but supervised learning. Supervised learning has two types. One is classification and another is regression. So, classification is a supervised learning method. In this, the input attributes are known as independent variables, as I told you already in the previous example. So, these are the independent variable. The target attribute or the class which needs to be generated is called the dependent variable, which depends on these independent variables or attributes. So, now this is the classification model we will get from this. In the classification learning, what happens that in the first stage where the training takes place, like how the teacher used to teach the student, like that only here training stage will take happen, in which the learning algorithm takes the labeled data set and it starts to learn. And after that data is processed, a model is generated. After generating the model, in the second stage, one testing data is given to the model. Then the model will test that data and it will assign a label. This is all what happens in the classification process. So suppose these are the data. This is a cat and this is a dog, as we know. So according to this label data, the machine will do what? It will generate a model by classifying this data. After generating the model, this is the test data, which is a cat. It will the classification model will search for this image. Okay, this is the image of cat. Now it will take this image and it will give a label as cat, that okay, the output will be cat. So this is how classification works. Even this classification is used for pattern recognition, object recognition, and all these things. This classification model already we have used in similarity based learning. Already that video is present in which KNN and all is present. It is also a type of supervised learning. So now coming on to regression model. Regression model is also a type of supervised learning, but what happens here is there we have discrete values, but here we have given the continuous values. This is the y-axis and this is the x-axis. So do we use this regression model? This regression model is can be used in stock predictions and all. So it takes some continuous variables like price. Here it is taking the price as its continuous variable, and according to that it generates a model in terms of a fitted line. And then after that, it will take some training set and try to it will try to find all the regression coefficients on the basis of this model. After finding the regression coefficient, it will put the x and y values according to that. Suppose if we want, we have the data for first, second, third, fourth, and fifth week, and we want the data of the eighth week. We can add up. We can form a formula for that, and based on that formula, we can put the value of eight. We can put the value of week as 8, and then we can find the prediction for the eighth week. Suppose a person who has sold 5 bananas in the fifth week, 4 banana in fourth week, 3 bananas in the third week. So according to that, a regression model will be trained, and according to that, in the eighth week, how much bananas should be there in the store, so that there is no not more than that number of bananas or less than that. So it will be easy for the seller also, so that the bananas does not get wasted and he doesn't get a shortage of it. For this reason, classification is used. So these are the two types of supervised learning. Both regression and classification are supervised learning algorithm. So what happens in the classification? Label data set is present, and then it uses the teacher and student method, and it trains the data and it finds the output. So this is all about supervised learning. Now we'll come to unsupervised learning. These are of three types: cluster analysis, association mining, and dimension reduction. So first we'll go to the unsupervised learning. Unsupervised learning is like self instruction. It has unlabeled data set. First of all, it has unlabeled data set, and it doesn't use any supervisor or teacher for training the data. So what it does is the trial and error method. It takes some of the attribute and distinguish among the objects. Like, okay, suppose again we are taking this example only, cat and dog. So we'll take the example of eyes again. Like cat has bigger eyes and dogs has smaller eyes. Now we'll distinguish between the objects. Like, okay, all the images which has bigger eyes will go in cluster 1, and all the images which has smaller eyes will go to cluster 2. This I have taken a simple example just to tell you. So like this, trial and error method will be done, and all the unlabeled data set will be disjoint into will be grouped into some clusters or groups, so as to continue the process. So this is the only thing which happens in unsupervised learning. So unsupervised learning are of three types: cluster analysis and dimensionality reduction. So what happens in cluster analysis? uh, Cluster analysis groups the object into clusters or groups, like they have done here, and then use after using these data objects, it is used to train the model, and then it will give the output to us. The k-means algorithm or hierarchical algorithm uses this unsupervised learning and cluster analysis only. In that, we have given a data set. In hierarchical algorithm, as I have discussed in my video, in hierarchical algorithm, what happens? We are given two data set. So based on this one, like if the attributes of this data set matches with the attribute of cluster 1, it goes to cluster 1, and the second one, if it matches to the the attributes of the second object, if it matches to cluster 1, it goes to cluster 1, or else it goes to cluster 2. This is how these both algorithms work. So this is about cluster analysis. Cluster analysis is nothing. Some objects, not objects, unlabeled data will be given to you. For based on the attributes, you have to group these unlabeled data into clusters or groups, and based on this only, You have to find out the respective output for a given input. So now comes the dimensionality reduction. It is also an example of unsupervised learning. What happens here is uh, it takes a in the dimensionality reduction, wherever like higher dimension of data or like large data set is present, it will be converted into lower dimension by taking the advantage of variance, by using variance, and then the task of reduction is done with a few features of originality. So why it is done like that? First point will be because if there are huge number of data set, as a number of the huge number of data set, first point will be huge. So now because of the huge data set, the features in the data set will also increase, the volume of the data will increase, and this will lead to some spurious data. So because of that, it won't give us the meaningful pattern or relationship which we want. So that's why we take the lower dimensions of the data, so that we will get only the proper patterns or relationship which is relevant to our for our reduction process. Now it is not good because the computational efficiency also, the computational time also increases, and the complexity is reduced. Like what happens if we take a less data set or low number of data? What happens, faster training will happen, and then model will get generated, and after that we can get the output in a less time, and there will be less number of errors if we take a small number of data set. A small number of data set, taking these data set is not mean, does not mean like we lose the generality or we lose the attributes. We have to take all the attributes which is important to our which is important for our machine learning. So this is the dimensionality reduction process in which we'll take the lower dimension. And I have also discussed the disadvantages with you, but that why should we take the lower dimension in dimensionality reduction? Now comes the semi-supervised learning. So semi-supervised learning has a huge collection of unlabeled and some labeled data set. Now for labeling this unlabeled dataset, it is costly and it is difficult because every data we have to take and we have to label it. So for that reason, the unlabeled data set will be converted into pseudo label, and then the learning will happen. This is the thing which happens in semi supervised learning. Now come the fourth one, reinforcement learning. Reinforcement learning mimics human being. Like human being uses ears, eyes to perceive the world and take the actions. So what happens? This reinforcement learning interacts with the environment, and it takes the knowledge from the environment and then it gives the output. The agent can be an human, independent program, or anything which gains the experience, and then it gives the output. So we'll take this grid game example. In this grid game, what happens? The gray tile, this one is danger. The black is blocked tile, and here you have to reach, which is the goal grid line. Or you can tell us diagonal line also. And the aim is to start from the bottom left grid from here. So what happens? The machine will interact with its environment, and it will take all the possible left, right, and top, all the possible path to reach the this state. So to solve this problem, there is no data. Like if there would have been data, we would have made a model and then we would have done this. But here we have to learn from our environment and then we have to do this. So which path it can take? If it goes from this path, there is a danger. If it takes this path, it is like block is there, so it can't reach. So it will take this path 1, 2 and 3, and then it will reach the goal. So after reaching the goal, which is the final destination, it will get a reward. Not getting a reward, it's like reaching our output or reaching our goal. That's all. In reinforcement learning, there is no supervisor or labeled data set. Many decisions are to be taken to reach to this final decision. So this is all about types of machine learning.